Hello, Professor. In this video, I am going to demonstrate the project of WCM555 course, and this project is completed by Oskar and Sujal Shrestha. In this demonstration, we will show how we use the GNU radio to analyze and demodulate the push-to-talk radio or a walkie-talkie signal. Our objective was to take a recorded file from a professor, process it through a custom flowgraph, and then recover the original audio message. A walkie-talkie commonly used narrowband FM or the NBFM modulation operate in VHF band, which is 136 to 174 MHz. Here is our full GNU flow graph. The file source block read the data sample which represents the RF spectrum around 146 MHz. Because the target signal was offset from the center frequency, we added a signal source producing minus 1.051 megahertz cosine. This X is our local oscillator, and the multiply blocks mixes these two signals. It performs the frequency translation, effectively bringing the desired signal to the baseband. Uh, After the frequency shift, the output goes to the low pass filter. We set the cutoff frequency to 12.5 kilohertz and then the transition width to 2 kilohertz with a Hamming window, matching the typical NBFM channel width. The filter also performs the decimation by 50, reducing the sample rate from 2.4 megahertz to 48 kilohertz. This step both removes out of band noise and lowers the processing rate for efficient demodulation. Next, we use a simple squelch block to suppress background noise when no transmission is present. Our squelch threshold is minus 30 decibels and the alpha constant is zero point 0.1, providing a smooth transition with the when signal appears or disappears. The clean signals then goes into the NBFM receiver, which perform the FM demodulation. We configured it with an audio rate of 24 kilohertz, quadrature or rate of 24 kilohertz, a time constant of 75 microseconds, and the maximum deviation of 5 kilohertz, which are all standard setting for the two-way radio systems. Uh, the demodulated output is sent to the audio sync at 24 kilohertz so we can hear the recovered voice. Now we will run the flow graph. You can hear the voice transmission from the walkie-talkie coming through clearly with very little static noise because the squash removes background hiss between the transmission, and overall the recovered audio quality confirms our parameters well tuned properly. So yeah, let's begin.
Good job. You successfully recovered the audio. Now make sure there is no static or noise in the signal.
Yep, that was the noise. To summarize, this flow graph uh, decode the sample audio provided by the processor and present the output which can be clearly heard without the background noises and all of that. In this project, we performed frequency shifting, low pass filtering, decimation, squelching in the narrowband FM demodulation, and finally the output, the recovered audio. This project was done by Oskar and Sujal. This project shows how software defined radio principles can be applied to decode real world walkie talkie communications. Yeah, this was our demonstration. Thank you for watching.